Diffusion, the international science radio show.
We have a bouncer on the doors of perception.
The good, the bad, the ugly.
It gets pretty exciting.
The myths, the truths.
Toxicology.
Astroseismology.
Magnetism. The dark side.
Genetically engineered potatoes.
Planetoid.
I love that word.
Hello and welcome to Diffusion. Sit back and relax while we cross-match weird and wonderful science in your brain. I'm Ian Woolf. This week, from the Consumer Electronics and Business Information Technology Convention in Sydney, you'll hear interviews about brain-inspired cameras in space and bringing academic expertise to commercial and social projects. First up, here's news of the end of privacy. Break the law to uphold the law. Clearview AI have stolen over 3 billion photos and videos by violating the terms of service and copyright from all social media platforms as well as photo and video hosting services online. Clearview AI are using the stolen photos to sell a face recognition service to police that can match your face from weird angles and even when covered by glasses and a hat. Some people have been identified from reflections in bathroom mirrors in other people's selfies. Over 600 police agencies in the US have signed up, and organisations like US Immigration and Customs Enforcement and the FBI. Clearview are claiming they can match your photo up to 75% of the time. But they have not had the rate of false identification tested by any independent party. When police violate privacy by uploading photos of people they suspect of committing a crime or being a victim of a crime into the Clearview AI database, the software converts their faces into a set of measurements and then displays the nearest matches of other photos along with links to the websites they stole the photos from, and information those websites have about people in the matched photo. The photos are also flagged by the system as of interest to the police, so they'll be matched more often. There's no word on the security of images in the system. When New York Times journalist Kashmir Hill asked police officers to run her photo through the database, the police soon got a call from Clearview asking them if they were talking to the media. This shows that Clearview are watching the watchman. After they realised that the journalist was asking police to run her photo through their database several times, Clearview changed the output that police could see so that no matches came up anymore. They corrected this when they finally agreed to speak with her for the New York Times article. This shows that Clearview can and will manipulate the results that police see from their service. You can imagine what might happen if someone that Clearview wanted to protect was a suspect in a criminal case. The two founders of Clearview AI are young Australian developer Hone Ton That, who moved to the US, Richard Schwartz, who worked as an aide to Rudy Giuliani when he was mayor of New York, and backed financially by Peter Thiel, the billionaire behind PayPal, Facebook, and their CIA-backed Palantir Technologies. They hired programmers to reverse engineer the software by reading scientific papers on the latest algorithms. Before they started offering the service to police, they offered it to white supremacist politicians like Republican Paul Nealon for voter engagement and extreme opposition research. Clearview have also adapted the code to work with augmented reality glasses so that users could look at anyone in the street and identify them, and find out with a click where they live. A study by the National Institute of Standards and Technology in the US found that anyone who's not a middle-aged white man is mismatched more often in all commercially available face recognition systems. In some cases, Asian and African American people were misidentified as much as 100 times more than white men. In Australia, New South Wales and Victorian authorities have confirmed to Fairfax journalists that they use face recognition technology as part of police work. But the New South Wales authorities won't say which software they use. Victorian police have been using the iFace software. Some private schools in Australia have also been surveilling students with cameras and face recognition software. And of course, the Australian federal government has been developing the capability since 2015.
And the National Facial Biometric Matching Capability. It's a system where photos taken of any citizen can be matched against existing databases which contain up to 100 million images to check identity. The images can come from driver's licences, passport photos or security cameras in your local shopping centre. There's no doubt this system, known as the capability, could be a powerful tool to catch criminals and run terrorists to the ground, but there are some key questions. How will it be used? Who will be able to access the database, and is it foolproof? In other words, could you be accused of something you didn't do because the system makes a mistake?
That was Tony Jones on ABC's Late Line in 2015. Clearview AI say they won't make the app available to the general public. However, it's just a matter of time before the security of their stolen photos is breached and someone copies their software to make stalking by face recognition available to anyone who wants to abuse it. You're listening to Ian Woolf on Diffusion Science Radio. Send emails to science@diffusionradio.com. We're brought to you across Australia on the Community Radio Network and podcast over the internet on www.diffusionradio.com. Brain-inspired electronics. Yesh Bethi works at the International Institute for Neuromorphic Systems. He's a research student at Western Sydney University. Yesh is investigating reinforced linked learning using neuromorphic systems. I began by asking him, what is a neuromorphic system?
So neuromorphic systems are basically electrical systems that are inspired by our brain, biological brain. They try to model our neurons and the processes that happen in our brain. So we have a neuromorphic camera here. It's a neuromorphic sensor. What it does is it basically models our retina. So the way our retina works is whenever you see any changes happening in front of your eye, that's when your retina gives spikes as an input to your brain, which goes through your visual pathway in your brain. So this sensor acts similar to that. It's kind of different from a conventional camera, which gives frames as output, whereas this one, each pixel talks asynchronously to the CPU. So each pixel detects a change. If there is a change in the light falling on that pixel, it says, oh, here, I see a change here at this location X, Y, and it's a positive change or a negative change. It's just a binary mode. So what we are doing here using a foosball table is basically to demonstrate the speed at which this camera works and the temporal resolution at which this camera samples. This camera samples at 1 megahertz, which is basically insane amount of sampling rate, because you can't find such kind of a sampling rate in normal cameras. If you want to do such kind of sampling in normal cameras, they're very expensive and they take in a lot of memory as well. So whereas this camera, when there's nothing changing in the scene, you don't see any data coming out of the camera. So you only get those events which occur at individual pixels. So we are trying to use those events, and based on those events, we are trying to figure out where the ball is on the foosball table, because a foosball is a really good example for how random objects can move around. So whenever you have a random object come into your field of view and you don't know what its motion is going to be, you want to get the position of ball with very high temporal resolution. So which is why we are using this foosball table to track the ball, and then we are basically giving a command to the players to say, okay, the ball is probably going to be here in future, so I want you to move ahead of the ball and then kick it. So this is a good demonstration about the capabilities of neuromorphic sensor, and it's just running on a laptop, so it has got a really low power rating. The same thing if you want to achieve in a normal RGB camera, you're going to need a lot of computing power and a lot of power in general. So we are basically coming away from that, and then we are saying we can make intelligent systems which are energy efficient, just like our brain, just like our body, and we're doing that.
And you're sampling what's happening a million times a second.
So it's basically trying to see at each pixel if the light falling on that pixel, if the illumination is changing. So it's sampling that light falling on it and the changes of it, and then it's saying within 1 or 2 microseconds, it can say, oh, I see a change in light here, and that's useful because you want if you especially want to deal with really fast moving objects.
So this would be amazing for robotics.
Yeah, this would be amazing for robotics. It would be amazing for all sorts of tracking and using it on drones, trying to avoid obstacles. And we also use it on satellites to track satellites. You can talk to Nic about it. So Nic does space situational awareness. So there are like immense possibilities with this new type of sensors.
What inspired you to get into this field?
It's a curiosity to understand a brain, understand how we work this way, whatever we are. So I have this curiosity to understand my brain and how it makes these decisions in a very energy efficient way. We don't need a lot of power, but we still do a lot in general. So we need to look at different ways of dealing with information, especially now when the whole world is running across deep learning or artificial intelligence, where we are throwing a lot of power at these tasks, and it comes with a cost because you are using a lot of power. What we want to do here is basically reduce the amount of power to do. You don't need so much power to do intelligent tasks. So that's what we hope to achieve.
Well, Yesh, thank you very much.
Thank you so much.
That was Yesh Bethi from the International Institute for Neuromorphic Systems. Also from the Institute is Nic Ralph. Nic Ralph works with event-based sensing for space situational awareness at the International Institute for Neuromorphic Systems and is also a research student at Western Sydney University. I began by asking Nic, what is event-based sensing for space situational awareness?
Okay, so break both of those up. So event-based sensing is part of neuromorphic sensing, and it's almost like the opposite to biomedical engineering. So we take technology out of the body essentially. So we draw inspiration from how neurons in the brain work and how the retina works. So we've used and designed silicon retinas, and they're event-based. So we only see things that change. We call these events. And so we use that to track satellites in space. And so this is a part of space situational awareness, or SSA. It's all about keeping aware of everything in orbit around Earth so we can mitigate collisions and protect Australia's space sovereignty.
There's a lot up there.
There's a ton up there, and if we don't do anything about it, we'll approach a Kessler scenario where we have sort of a cascade effect of collisions. We won't be able to have any space-based systems. We won't be able to have any launches from Earth, anything like that, if it's a minefield.
So basically, if everything collides with everything else, there'll be so much debris, it'd be too dangerous to send anything up ever.
That's right. So a 1mm paint fleck travelling at 40,000 kilometres an hour is catastrophic. It might as well be a bullet.
So all this talk about space-based weapons, I think Arthur C. Clarke once suggested all you would need is a bucket of nails in orbit.
Yes. Yeah, absolutely. So there's been a couple ASAT or anti-satellite tests done by a few different international agencies, and there's a variety of different methods, but generally speaking it results in a pretty big cloud of debris.
So are you mounting your cameras in telescopes here, or are they going to be on the satellites?
So a little bit of both. So we are mounting them terrestrially on the end of a telescope here. We have the Astrosight, which is a deployable, maneuverable observing platform built into a shipping container. But we have 2 planned launches over the next 2 years on notable space-based systems. So we can perform this space situational awareness from the ground and from orbit.
And so will you be launching CubeSats to test this?
No, so a larger class of satellite than CubeSats. Both of them will be in low Earth orbit, where most of the action is. Yeah.
And how is that being funded?
So that's being funded by a couple different defence agencies. So I believe the Defence Innovation Hub might be part of that, but also AFOSR in the US as well, I believe.
And has the Australian Space Agency spoken to you?
Not to me personally. I'm really from the algorithm development side, yeah. Not so much policy and funding or anything like that. So better figures will come from other people than me, yeah.
And how did you get into the project?
So I graduated my undergrad in mechatronics here at Western. I did a master's machine learning in astronomy, and that kind of combination of vision, machine learning and looking up really meant that I was able to fit in all right with the group, given they're using these very novel sensors to perform space imaging, essentially. Keep an eye on this space. Space industry is closer than you think. Now that we have our own agency, there's going to be a lot more opportunities and supporting roles in that as well. And space situational awareness is one of many other commercial sort of applications, yeah.
Well, Nic, thank you very much.
No worries, thank you.
That was Nic Ralph from the International Institute for Neuromorphic Systems and Western Sydney University. And finally, bridging the gap from academic engineering expertise to real-world problems, Hervé Harvard is the director of Rapido at the University of Technology, Sydney. I began by asking him, what does Rapido do?
So Rapido does technology development for industry partners. So traditionally, the university sector in Australia has that, it's always challenging to ensure that the expertise that is available through university, delivers value to industry. So that's why we created Rapido 3 years ago to help industry tap into the incredible expertise that is at the University of Technology, Sydney. Now, the way we do that is we have a dedicated workforce made up of R&D engineers that will work together with academics to create a multidisciplinary team that will focus on the business value for our industry partners. And we've done that over 3 years with many companies with a lot of success, and we've been able to establish long-term relationship in the R&D space with startups, large companies, small and medium enterprise, and government agencies.
What sort of things have you been developing? Like, you've got some robotics and drilling things on display here.
So here on display, we've got two particular R&D relationships in display. One is with Dana, so a very large group here in Australia, and more particularly with the Mineral Technology Division in the Gold Coast. So we're doing our third project with them, and this is around creating a 3D printer that will produce a functional separator that can be used on mine sites. So these are large mining pieces that separates the slurry on mine sites. The other one is with a company that was a startup when we started with them 2.5 years ago called Speed 3D out of Melbourne. They are trying to revolutionize metal 3D printing, and their technology is amazing. So they will print a metal piece in like 20 minutes rather than 20 hours. We have a second project now with them, and we're focusing on the vision system. So we're developing a laser-based vision system. So the first one we've done is mostly a mechatronic with embedded software. The other one is actually a lot of robot control, which is software, and a lot of geometry processing software, which is the processing of 3D data in space. We have many other partners and projects, both in the mechatronic space and in the software space. And for most of them, we've started with a first project, and when we continue and we develop an R&D relationship, which is well aligned with our ambition to provide solutions for the industry, and in the area of Rapido, this is an R&D as a service model.
So you're providing expertise and access to the researchers, but because you're professionals, you're also solving the problems of industry.
That's exactly right. So one thing that is very important to us in Rapido, and I think in the broader university, is something we studied 2 years ago called Rapido Social. And we did that because we realized that social impact organizations, particularly smaller organizations, can benefit from technology in the same way larger commercial organizations can. The issue is they're lacking funding. And what we wanted to do is be able to help them with their technologies in a pro or bono fashion. So we've done amazing work with a number of organizations like the Thomas Kelly Youth Foundations, Field Ready and others. And I thought if you want some example, I've got Sophie Ritchie here, who is our social impact manager and can tell us more about it.
Sophie, hello.
Hi, and thanks for, the airtime. So my name's Sophie Ritchie. I work in the capacity of a social impact manager at UTS Rapido. I think what I'd like to talk about, just very brief, few examples of the types of work we've done in the engineering for social impact space. So I think as Hervé mentioned, we've got a social impact offering for the non-profit, for-purpose sector called Rapido Social, which looks at how cutting-edge technology can help benefit social justice matters. To date, we've done quite a lot of really interesting work in the tech space. So to elaborate on an example in the 3D printing space, we've done quite a bit of 3D printing sort of in orthotics and in prosthetics. So we've worked very closely in collaboration with a Sydney-based startup called Ability Made. Ability Made have a specialisation in 3D printing ankle-foot orthoses for kids with physical disability. The reason why 3D printing is so interesting in this context is because the traditional way of producing AFOs is really unoptimised. So it's slow, it's expensive, and I think very importantly, it's quite traumatic for kids and families. So 3D printing is a bit of a sort of answer to a lot of those challenges in that space. And we've worked with Ability Made to make some 3D printed orthoses available, in particular to kids from refugee backgrounds. Also in the kind of mechatronics engineering space, we've worked recently with a humanitarian engineering organisation called Field Ready and HitNet actually, and we've worked in collaboration with these two other engineering outfits to drive a digital literacy program in the Solomon Islands, and that's particularly important because the Solomon Islands sort of fall victim to natural disasters quite often. So we've worked with HitNet and Field Ready to install solar panelling on Wi-Fi kiosks in certain parts of the Solomon Islands, and we've used our sort of engineering expertise to drive that collaboration. And then I think the last example I'd like to sort of touch on briefly is an internal project we've done with a legal academic in the Faculty of Law from UTS. With this academic, we've actually developed a really interesting flagship platform in the kind of legal and software space. That platform is called the Gender Legislative Index, and what that platform actually allows legal experts to do is to classify pieces of international legislation on a spectrum from gender regressive to gender responsive. So what that tangibly means is that lawmakers, so legislators and civil society organisations that lobby for the effective creation of laws are able to make those laws more friendly towards the rights of women. Notably, I think it's worth mentioning that a lot of this work we've done has been on a pro bono basis or a low bono basis, so heavily subsidised.
And how long has the Rapido Social been going?
Rapido Social began in, I think, mid-2017. I might let Hervé speak to that because he was the person that sort of built it up.
So Rapido Social was first studied as an idea in the early 2017. It was well supported within the university because it is genuinely something that is of primary importance to UTS. And I believe for me a big milestones, we started work with social impact organizations before that, but a big milestone was Sophie joining the team to drive the program. When did you start, Sophie?
In May 2018.
In May 2018, so probably it gives you a bit of a time frame there.
Yeah. One thing I would like to add actually would be a bit of a call to action for other engineers sort of working in the field that might be interested in social impact or humanitarian engineering. I think sometimes it doesn't seem like an obvious path to explore for a lot of technical people. But what I've sort of witnessed over the past 18 months or so of managing the program, that there's this really, really high impact nexus of technology and social impact. And I'd really implore more engineers, if they are interested, to sort of explore options in that space. And then always a bit of a cheeky plug for the Rapido social program and I think for sort of like-minded organisations that might be looking to support similar initiatives. I think engineering and social impact are very worthy causes to fund, both from a corporate perspective and then I think for government funding as well.
Well, Sophie and Hervé, thank you very much.
Thanks, Ian.
Thanks a lot. Thank you.
That was Hervé Harvard, Director of Rapido, and Sophie Ritchie, the Social Impact Manager at Rapido Social at the University of Technology, Sydney. And that's all from us this week on Diffusion. Are you a scientist, artist, biohacker or maker who'd like to be interviewed about your work? Would your company like to sponsor Diffusion? Send your contributions, opinions, helpful suggestions and donations to science@diffusionradio.com. That's science@diffusionradio.com. Please like the Diffusion Science Radio page on Facebook and rate the show on iTunes. Tell your friends. Follow me on Twitter @Ian Woolf. The news music was Rhinos Theme by Kevin MacLeod of Incompetech.com. Join my patrons at patreon.com/diffusionradio. Make a donation through paypal.me/IanWolf or buy through the affiliate links on diffusionradio.com/support. Subscribe to the Diffusion YouTube channel at youtube.com/c/diffusionradio. I'm Ian Woolf. Join us inside your audio device of choice for more science wondering next week on Diffusion Science Radio.
Science is fun. It helps you to learn, to know, and to appreciate. When you study science, you may go on field trips. You discover the marvelous interrelationships between all living things. You learn to read the history of the Earth as it is written in rocks and fossils. You find out what makes things tick, everything from a molecule to a living organism. In the study of science is found the most useful and satisfying knowledge of man. Knowledge of his physical world, its past, its present, and its future. And in your moments of relaxation, now and in the years to come, you will find the study of science leading you into fascinating pursuits. Photography, collecting. Why study science? Study science because you will find in the study of science a richer, more rewarding life.